Hello my dear students, this is Visalakshi from Avinashlingam University, Coimbatore. In the last session, you have learned the importance of light in designing interiors. Today, the session will be on another vague aspect in the ambient atmosphere which can leave an indelible impact on the space that is designed. Utmost care needs to be bestowed on this factor as the sensations a home can offer is highly dependent upon the control of sound and noise in interiors. We are bombarded with sounds of various types from the moment we wake up. Birds chirping, milkman's bell, street vendor and what not. Have you heard these sounds? Could you identify? Very good. Hundreds of various sounds are also distinctly identifiable. Listen, what are these sounds? Did you all hear? All of us know that sound exists and that they are distinguishable. Then what is the purpose of studying about sound? It is part of our environment and our entire activities center on some kind of sound. So there are a few concrete objectives behind offering this session. Obviously, on completion of the session, you will be able to understand the basic concepts of sound and noise, learn how they are formed, comprehend the secret of hearing, differentiate sound and noise, study the need for controlling them in the interior. All living beings hear those sounds you just heard, but each has a different range of hearing and a purpose when it comes to sound perception. So, how is sound perceived? Sound is perceived as vibration, as signal, as nature's sound, as sound of nature's events, as sounds of special organs, and overriding all these is man's success over this perception. He has developed his ability to generate, communicate, distinguish, document and transmit and to broadcast sound. Well, what is sound? For physicists, propagation of vibrations as mechanical waves which move in varying pressure and displacement, which are passed through different mediums like air, water, etc., and which are audible, refers to sound. The scientific principles of physiology and psychology regard this phenomenon to be specifically related to oral reception of such waves and the brain's attribute to perceive it as a sound. The field of psychoacoustics is a dedicated branch of science that deals with studies of the above phenomena. Psychoacoustics, what is it? It is a scientific study of sound perception. It is a branch of science studying the psychological and physiological responses associated with sound, including speech and music. It is further categorized as a branch of psychophysics. It highlights the relationship with man, his abilities, limitations of hearing and the formation of the human ear with the broad science of physics. In all organisms which have a hearing sense, the physical reception of sound is limited to a range of frequencies. Have a view of the Ling-Long chart to know how different organisms are created with different hearing abilities. Human beings normally hear sound frequencies approximately between 20 Hz and 20,000 Hz, that is 20 kilohertz, though sounds are heard best from 1000 Hz to 5000 Hz where human speech is centered. These facts justify why we need to study sound in different angles. First, let us consider sound as waves. Anything which vibrates always creates a wave, and a wave thus formed in turn always moves through a medium such as air and basically displaces the air particles in an oscillating pattern typical of the material and the medium. Vibration causes the object to exert pressure on the air molecules around it. These in turn push on other molecules around them, thus creating a wave that moves and ripples away from the source of vibration. Precisely, sound is a wave of energy traveling from a source, that is surging back and forth, alternately squeezing and stretching the air as though in vibration or oscillation to one's ears. Rooms where air is lacking, spaces devoid of air, or a vacuum can hinder travel of sound. Hearing difficulty expressed when people are in space is because of this reason. Science distinguishes the congested parts of air as compressions and the stretched parts as rarefactions. Now you can see the animation. The concept of wave propagation explains sound propagation. In air at normal temperatures, the speed of sound wave transmission reported is approximately 340 meters per second. The sound vibrating from any source causes a sort of disturbance to the molecules of air surrounding the area, causing them to bombard and bounce off each other. The force with which they do so is proportional to the disturbance that is affected. This radial movement at equal speed forms a spherical wave front which expands the boundaries of an enclosed space and fills the entire space with the rapidly moving spherical sound wave fronts. Consider a point source emitting waves. If the emitter is placed in the center of a hollow sphere of 1 foot radius, the total emission of the source will fall on the whole surface of the sphere, that is on 4 pi r squared or 12.57 square feet. Change in the radius over short distances does not alter the frequency of waves which give sound its characteristic tone. You can see this for yourself in the next slide. Our next concern is to understand how sounds propagate in an interior. Sound propagation in an interior considers sound wave fronts in an interior. They normally strike a wall, floor or ceiling and are reflected in various directions. The reflection process continues until all the energy released through vibration to the original waves is absorbed and the sound fades away. Imagine you are dropping a plate. The sound keeps reverberating until and unless the vibration subsides and the sound dies away. Those who are near the spot hear it louder and those in the corner also hear it, but depends upon the force of drop, the material of plate, the flooring, size of room and the individual's hearing ability. Same thing happens when you try to create sound by rubbing the edges of a bronze vessel. Then how do you hear? See the figure. Here is a wave in 2 dimensions. Imagine the dots in reds are air molecules. When animation is applied and played, the dot at the center, the one in yellow, will suddenly expand. Sequel to its expansion, it pushes on the air molecules that are adjacent and thereby closely surround it. It is at this point that the wave begins. Imagine that the red dots are air molecules. Now an ear is nearby. The yellow dot will expand and then collapse, creating a wave in the air molecules which reaches one's ear. There lies the secret of hearing. And what happens here? These actions and displacements explained earlier are affected by the interaction that takes place among the molecules of air, causing ripples. The impact is generation of energy, whereby the air molecules are transformed into those displaying pressures above or below normal atmospheric pressure. Hence, they appear as denser or less dense molecules or ripples respectively. Now have a look at the figures present in the slide. In the natural sequence, 2 types of density areas occur, causing compression and rarefaction. Hence, the back and forth oscillation of pressure is said to produce what is called sound waves. You will understand this better from the next slide. See the sound waves in animation. Hope the concept is clear now. What do you understand from this? If you ponder deeper, it will be clear that displacement of air with change in pressure produces a sound. Then how do you hear? Yet, we don't have an answer for this. Further analysis proves that it is because of sound waves and sound pressure. A rapid variation caused in the density of air molecules differing from existing or ambient atmospheric pressure, which also happens in a sequence, is hence said to produce sound. This sort of pressure fluctuations can cause human beings' eardrums to vibrate, which is ultimately perceived as sound. How do you explain this? There exists a difference. When referring to sound, scientists generally discuss these minute changes in pressure usually occurring in atmosphere as sound pressure and the actual fluctuations evidenced in pressure per se as sound waves. To be more precise, anything that vibrates fundamentally produces sound waves. It is understandable, therefore, that sound like light is also a perception by all organisms with hearing ability. See the animation models in the next slide. Precisely, dual aspects related to sound enable effective perception. One relates to a physical process that initially produces sound energy and sends it shooting through the air, and the second relates to a separate psychological process, essentially an internal process which happens not only within one's ears and brains, but which also assume the major role of converting the incoming sound energy into sensations one interprets as noises, speech and music. The tiny hairs inside the ear get vibrated by the vibrating air molecules which stimulate the nerve cells. They in turn send signals to the brain. Reception and perception of these signals as sounds is actually done by the brain. So hearing is a wonderful process. It is no wonder that people find some unique features with sound. From these we come to understand the unique features of sound. What are they? Like light. Sound also emerges from a definite source, a musical instrument or a noisy automobile. The similarity ends here. They differ in a major way. Light can travel through a vacuum. Sound, however, cannot travel through a vacuum. It always has to have something to pass through, generally known as a medium, such as air, water, glass or metal. Allen has estimated sound to travel at one of the fastest rates through aluminium at about 6,320 meters per second. The next fastest speed for sound he adds is 4,600 meters per second in copper. All these facts bring out the secrets of sound that make it so mystic. Before we go to the secrets of sound, just think about the important and interesting facts you have learned today about sound and hearing. The term sound has different connotations in different disciplines. Sound is a mechanical wave which exerts force to push air molecules for transmission. Sound is a longitudinal wave. Vibration is parallel to the direction of sound wave movements. Hearing involves physical, physiological and psychological processes. The tiny hair follicles in the ear and brain share an important role in the hearing process. Source of sound and space in which the waves disperse have a decisive role in sound propagation, hence their importance in designing process. Now let us see what is so mystic about sound. There are 6 major mystic facts related to sound. Sound is caused by a vibrating body which requires a medium of transmission. Sound waves are the vibrations of an elastic medium which provide the stimuli for hearing. If in air, sound waves travel in a speed of about 1100 feet per second or 760 mph or miles per hour. The speed of transmission through water is about 4 times greater than in air. Sound waves do not pass through a vacuum. Sound always has its origin from some source. Such vibrations get transmitted through multiple media. What is our real concern? The basic concern rests with those transmitted through the atmosphere to the ear. The natural world is filled with sounds of varied types produced from nature herself. This is even truer of the man-made artificial world. In the combined state, in fact, it is fit to cause a multiplier effect. Human beings and all organisms are surrounded with objects and things made of various materials. Whenever an object sends out vibrations, a person is able to hear, that is, between 20 and 20,000 cycles per second. It produces sound energy. 3 things happen without our own knowledge. Vibrations are carried through different medium. Different forms of energy, mechanical or electrical, make objects vibrate. Energy radiates as sound. It's an important factor in designing space. We have to think about it very religiously because energy released from different sources is heard as different sounds. What are these sounds? Where do they come from? You would have identified the pictures given for sounds of surf, thunder, a noisy object or a gust of wind. Sound energy from water falling and hitting a beach is what one hears as surf. Heated air from lightning is heard as thunder. Objects set into vibration make noise because they are hit by the wind, produced by heat from the sun, but the same wind can cause gusts when they howl against it. These are natural sounds. What a wonder, but think a little. What are the impacts and how to control them? No, we never think. Everything happens without us even noticing, perceiving it to be precise. No more this should happen. Stand anywhere in your surroundings and hear the sounds around you. Simultaneously think whether you hear any of these within your house. How are you preventing it then? Our perception skills need to be sharpened more. You may wonder why. Do a small experiment. Stand with your eyes closed. See if you can identify voices around you. Is it your mother calling? Can you feel an automobile pass nearby? How clear are you in distinguishing the sounds? And here is where we are describing sound. You will say, I heard Meera's melodious voice. I heard the loud bark of a dog. Sneha whispered something to Usha, a secret. Now you even know to identify if they were louder or softer, high-pitched or low-pitched, a shrill or a shout. But if I ask you to differentiate one from the other, you may not have an answer. So everything is your perception, as all these words describe, characterize perception of sound. This is your method. Scientists, on the other hand, look at it in a different way. For them, sound is measurable. For this, you must understand how we describe sounds differently. A sound can be explained as loud against soft, differently pitched as low, high, whisper, shout or a shrill. These words describe the way people express sound perceptions. For scientists, sound has measurable characteristics that can be measured using instruments. An understanding of the physical qualities of sound is therefore necessary. Sound has measurable characteristics that can be measured using instruments. To register this aspect, you should be aware of the physical properties of sound. Why? While designing interiors, you will not know the types of sounds that the rooms may be exposed to, how the room may respond, the type of people who will inhabit, their tastes, age group, preferences, so on and so forth. Generally speaking, people can draw relationships between such measurable characteristics to the descriptions given colloquially to the sounds heard. For example, when laymen describe a sound as heard louder or softer, scientists discuss them in terms of the sound's intensity or amplitude. When he talks about the pitch in which it is heard, scientists call it frequency. That is a problem. Have a look at the chart. Loudness and pitch are called perceived characteristics, while intensity and amplitude are called physical characteristics. As stated, comprehension of the difference between the perceived characteristics of loudness and pitch and the physical characteristics of intensity and frequency of sound becomes imperative, especially for designers of space, because they only decide the nature of the space. This is why we study noise and sound in a designing space. For practical purposes, further learning on how sound waves are explained is necessary. Sound waves are explained as sinusoidal plane waves. It is a popular method used to explain a sound wave. They are characterized by certain generic properties such as wavelength, frequency or its inverse, the time scale, amplitude. These two are considered the attributes of sound, wave number, sound pressure, sound intensity, speed of sound and direction. Let us learn about each property. First point is wavelength. What is it? A wavelength refers to the length of one wave from the beginning of its oscillation to the end. You can see that in the figure given in slide. Wavelength determines the frequency of a sound wave. It is clear now. It's because of the other attributes of sound. And what are they? Like other waveforms, light and water, sound can be defined in terms of its frequency and amplitude. So the two primary attributes of sound are frequency and intensity or amplitude. While the single sound or pure tone can be represented as a sine wave, the complex tones are made up of a mixture of superimposed waves. Now register a few terms related to these attributes. Frequency, high or low pitched, indicates just how often the waves occur during a particular period of time. Sound waves form a recurring design, a wavy pattern. One such wavy pattern is known as a wave cycle. Frequency in sound indicates the count of cycles of sound waves recurring in 1 second in hertz. Human hearing interprets frequency as pitch, which is heard as low or high. Increase in sound frequency will show more cycles per second, and that is when sound is described as higher pitched. An action in the opposite produces a lower pitched sound. Loudness, on the other hand, is a sensation in human hearing and is well explained as a reception by the ear and its interpretation by the brain, attributed to the sound wave's amplitude and its frequency. Loudness describes how people perceive sound. As the sound wave passes by, they cause a change in pressure, which is defined as the wave's amplitude. Greater the amplitude, greater the pressure transmitted by them, and this is called as sound pressure. The amount of energy it carries is said to be related to its amplitude. These figures, which are self-explanatory, will help you distinguish one attribute from another. You would have understood all the characteristics and the basic differences between each. The quantum of energy passing through a specific area in a specific time interval in a specified direction is called the intensity of the wave. Higher the intensity, louder is the perception. Sound intensities are referred to in units called decibel. To summarize, perception of sound is attributed to these two aspects. Now you would have come to know about certain interesting facts. What is frequency? It determines the tone, the sensation perceived as pitch. Amplitude determines the intensity, and the sensation perceived as loudness. So by virtue of these obvious reasons, a sound can become a noise. A sound becoming a noise is therefore dependent on its source and the sound level. See for yourself in the next slide. You will see, except the whisper, sounds from other different sources are heard in different sound levels. Even our day-to-day sounds like a radio talk, a child's cry, or a vacuum cleaner in use are heard in higher decibels. Now you would have understood the difference between frequency and intensity. You should also hold in mind that there are factors which convert a sound into a noise. Ultimately, the decisive factors for noise are the source and its sound level. Do we ever wonder or bother about the various sound levels that surround us? Try to find out the noise levels emerging from different sources and identify those which people will designate as noise or unwanted sound from those you hear now. Probably you will also agree that unless control is practiced, all sounds can become noise, which can affect our well-being and our active life. Though we don't think about the characteristics of sound, we show great concern to avoid noise, especially in interiors. This needs becomes all the more necessary if there are elderly patients, residents, convalescing patients, infants or toddlers. You will unconsciously feel the necessity to differentiate sound from noise. You would have experienced a sound you like also to be perceived as a noise at times. For example, a piece of music you enjoy may not be relished when you have a headache. People, age, occupation, the situations, space available, ambience in a room all have the ability to transform sound into noise. We don't try to avoid sound, we try to avoid only noise. And that is what we have been doing in designing spaces, let it be a hospital, study room, library, theatre, etc. Don't you agree with me? Let us differentiate sound and noise. The mixtures of sounds are known as noise. Understood? Hear this audio clip. Can you identify the various instruments used in this number? Are you able to enjoy the instruments played? Don't you enjoy that instrument? When it is not played well, it becomes a noise. Then noise is expressed as a sound spectrum in which the amplitude of the component frequencies is plotted against the frequency. But noise is also a term used for referring to any unwanted sound. Naturally, it depends on the type. How are they classified? There are two types of noise. Broadband or white noise, which can cause deafness and reduce one's work efficiency, and two, meaningful noise, which interferes with one's efficiency and makes communication difficult. Is it advisable to get exposed to such kind of noise? Definitely not. Any space for habitation has to be manipulated to avoid noise. Two major reasons gain emphasis here. And what are they? The risk of damage to the ear is not uniform over the whole frequency spectrum, but appears to be greatest for sounds between 2400 and 4800 cycles per second. In addition to any damage caused by noise, hearing loss known as presbycusis can also occur naturally with age. Arrangements need to be made to prevent this condition happen to the inmates. We are of late living only in the centuries of noise, though 20th century was named so. But now, noise is a major stress factor in man's environment. Look at the table. The table explains very distinctly the common sound levels to which people are exposed to almost daily. A look at the next table will prove how far we are prone to the risks of damaging our hearing. The maximum loudness or limit recommended for man is 85 dB or decibels. When designing an interior, the designer has to be doubly careful to see that the areas permit only the acceptable noise levels expressed in dBA. The next slide helps you to become smart by enabling only the permissible noise levels in an interior, a must learn for a space designer. Have a look at the table. For qualifying as acceptable noise, the range extends only between 20 and 60 dBA. But what are the levels that we expose ourselves to? Sound from the exterior cannot be controlled unless the source and the receiver are controlled, but sound produced in an enclosed space can be controlled, which we will study in the forthcoming sessions. Dear students, scope of this module was to familiarize you with the various attributes of sound which have to be understood, permitted and or prevented in an interior of a building to make living more comfortable and pleasant. Lack of concern for these issues may end up creating an interior which would hinder not only with one's physical comfort but also with one's mental balance. The impact can be felt in one's temperament, self-control and work productivity. I conclude with a note that an interior therefore has to be created which will only evoke sensations of enthusiasm, calmness and being proactive. You need to know about a few more aspects related to light and sound to emerge successful in designing such interiors. The following sessions will introduce to those factors.